much for bearing with me and for doing this along. Okay, so here we go. So my name is Jeanette Camacho, and I am currently a Samsung education coach. However, my dedication to education has been ongoing for about 25 years in the field of education. I've served in diverse roles, and this is a breadth of experience that has given me a unique perspective into the many facets of our education system. As a teacher, I gained firsthand insights on how to best support and engage my students. As an administrator, I understood the behind the scenes work required to run an effective school. And one of my proudest accomplishments has been to start a 101 computer program back when computer programs were not computers 101 were not even a thing. So I have my camera off because I'm trying to troubleshoot everything. The code for the Nearpod is XR. Hold on a second. Let me go again. XR7P6. XR7P6. I'm putting it in the chat again. Okay, so you should be looking at the overarching question. How do you envision your role in computer science in shaping 21st century skills? And what barriers do you think exist in implementing an effective program? So, okay. If by any chance you do see a white screen and my computer is not even allowing me to share my slides, I am going to put my slides in the chat as well, so you can follow along, even though it's not going to have any of the interactive components that I wanted to ensure that you guys had on this presentation. So I'm going to go ahead and share my slides as well. And thank you so much, Jamila, for saying that if you refresh it, it goes away. So breath of fresh air to know that this is that we're troubleshooting even from abroad, so from over there. Okay, so how do you envision your role in computer science and shaping the world? If you don't have access to being able to see that, okay, thank you, Matt. I'd be active in facilitating, providing a vision. Okay, so that is true. And with a vision in mind as an educator, we're going to go through the whole entire process of what it takes to even get it started at your school, whether you're a teacher or an administrator that is looking for a way of being able to get this started, to make sure that you're in compliance, to make sure that your students are getting what you are putting into this program, your hard work. Okay, so computer science, very good. Thank you, Heather. I'm a network site tech director, so we teachers ensure that want-to-use work is done in our district. Perfect. Okay, Sarah, great. Jason, thank you so much. Okay, that is true. It's and I can truly attest by the fact that, and then I can attest by the fact that that is an issue, and we're gonna go through some of the items that you can actually do in order to make this happen, to make sure that your teachers are not overwhelmed, and you can slowly put in this process into place. Okay, so we're going to go ahead and jump over. Before I even get started with my presentation, I know that I wanted to give a plug to Solve for Tomorrow. Those of you who have not heard of Solve for Tomorrow, this is a program sponsored by Samsung, which students who create a problem, or if there's a problem and your students come up with a solution, and by any chance your students win, your school is rewarded with $100,000 that could be utilized for any program that you want to implement or any software that you want to purchase. Samsung provides you that type of funding for it. So, I just wanted to put that out there, just because it's such a great opportunity to enhance the initiative of STEM and the initiative of probably adding computers to your classrooms or additional items that you might need in order to get this started. Okay, so really quick tool, and if again, my apologies if you don't see it. What do you perceive as the most critical factor for successfully implementing a computer curriculum aligned with New York City CS and DF standards in your school? So, what do you think one of the main critical factors is going to be? I know that I asked kind of like that similar question. I asked, what do you think are your problems that you're going to encounter? But thinking about the problems that you're going to encounter, what is going to be your main what's going to be your main goal, as far as like, okay, I know I'm going to encounter these type of problems. How am I going to attack those problems, and how am I going to fix them, and how I'm going to make sure that my program is successful? And with that being said, as far as that, what is going to be your main goal for this coming school year? What is it that you want to ensure that that you gain from it? So let's get started. Let me see if a couple people voted in. Awesome. Okay. So on my teacher view, right? And I'm going to share with you guys as far as, what is the main problem that, and it's alignment with the curriculum. And I'm glad you guys chose the alignment with the curriculum as one of the main issues with a 50% concern, because that is exactly what we are going to be talking about and giving you a guideline as to how we're going to make that happen. Okay, so I am going to scroll through my first slide, and this is my 10-step blueprint for launching a successful computer program. And again, I'm going to take you through each of the steps, give you ideas, give you examples of how this could be done in your classroom or in your schools. Okay, so starting with number one, your program vision, right? So we are always comments with the with the most crucial step, your program vision, which considers this the architectural blueprint of your future program. What's going to be your core value, right? In the program, is the program geared towards computational theory or towards industry readiness? And as we just saw from the last guest speaker that we listened to, is trying to meet those gaps in computer science in our schools to ensure that all students have the right equity. So we want to make sure that we collaborate with all the key stakeholders, whether it's faculty, administrators, students, alumni, to create a multifaceted yet unified vision. Remember that your vision should also be aspirational and grounded in the practical. It must be broad enough to accommodate the growth, yet anticipate enough to provide a direction for your staff, for your students. And I'm going to go back to this slide for a second, because on the actual PowerPoint that you guys also have access to, I hyperlinked each of these books to their correspondent PDFs, so that your teachers have access immediately through the website or through the link if you're going to share this with your teachers or with other fellow staff members, because it has everything pretty much aligned for them to follow and see an example of how to push forward a curriculum in your schools. So your next slide is you're looking at the 4th through 6th grade guidelines. And notice the colors that they're selected. And I know this sounds, ridiculous that I'm actually telling you to look at the colors. We just had a whole discussion about colorblindness, but I want you to look at the colors because I set out the teacher lesson plan templates for the whole entire year, set up by the colors of each of the strands placed on the K through 12 computer science digital fluency learning standards. So you're looking at the 4th through 6th grade one, because I am going to show you on the coming slides a link that is going to take you through the actual lesson planning or your curriculum mapping guide. So we said that you first start with your vision. Where do you want your vision to go? And your vision has to be guided by your curriculum design, right? How are you going to design this particular vision to your school, right? So we know that the vision for our computer science standards is that every student will know how to live productive and safely In a technological dominant world, this includes understanding the essential features of digital technologies, why and how they work, and how to communicate and create using those technologies. In the world that we currently live on, every single thing that we are looking at, it's now going to involve even more technology at hand, especially with everything going on with AI in the workforce. More and more businesses are talking about AI and how it's being implemented, to the point that University of Florida, just one of the many, MIT, just one of the many universities right now that are currently making sure that their curriculum is aligned to train every single, forget about computer science field students, they're actually training every single field in mathematics, in fine arts, and law, ways that they can implement AI and how this is going to impact their education. This way, when students are graduating for a specific college, they are not in shock, and they can make their degree relevant to what's going to be their future in 4 or 5 years. So I'm going to go ahead and close this off to move to the next page. Um, so what you're looking at right here, and hopefully it loads. It's not loading for me. Okay, so if you scroll down, this is a template that I put together, and I have it set up for a trimester. You can fix it up and you can make a copy it for yourself and change it to quarterly. But if you scroll through that template, you're going to see how it's color coordinated according to the standards. I created just a simple lesson plan that you can see for Monday through Friday of what your Monday through Friday curriculum integration would be. Now, part of your vision is saying, okay, how am I going to be incorporating this into my school? And we're going to talk about the different models that different schools have, and the different models that schools can possibly incorporate if you don't have the funding to have a computer lab, and how to bring this about. But this is a great guideline that your teachers can add on to their lesson plan. The lesson plan template's already set up for them. All they have to do is link there or put their lessons and how it's going to incorporate with the computer program vision that you have to introduce CS in your schools. Okay, so, and again, I am going to give you guys access to all of this at the end if you didn't have it. I know that some of you are looking at it right now through Nearpod, but I will make sure that everybody has access so they can copy this particular template. And as you can see, again, it's sorted by the colors. The dates are already there by the weeks. You can alter it, pass it to your teachers, pass it to your administrators. This is just another way that we can make this a little easier and less stressful on educators when putting this forth. Okay, so I'm going to go on to my next slide, right? And it talks about staff identification, right? So on staff identification, we need to think about, either as an administrator, your talent acquisition in academia is both an art and a science, right? So we have to look beyond just qualifications, pedagogy skills, industry experience, and interpersonal qualities when we're thinking of hiring. Because right now, you might not have the money to, or the funding to hire a computer science teacher at your school, right? So now it's, okay, I want to put this into place. Who's going to be the right person for this particular position? Or how are all these teachers going to play a role in this particular decision that I'm taking into place? So recruitment should be and aligned with your program's vision, your curriculum needs. Remember to consider roles beyond just a lecture, right? So lab instructors, teachers assistants, even industry guest speakers who can offer specialized experience. Make use of rigorous but fair selection process, and perhaps even involving peer review and demo lectures, right? So if you're thinking of interviewing a teacher for the position and you have a couple people that are interested, to say, hey, can you come up with a lesson, and just you're going to teach it to me and a couple of my administrators, and see which lesson or which teacher has a better understanding of how to relate to that specific set of students, and to ensure that those lessons are geared for not just the very bright students, but for everybody in that classroom, so that all the lessons are going to be equitable for everybody. Okay, so in talking about your professional development, so let's say that you do not have the funding now to hire a particular teacher or have a computer lab, and you want to adopt a model where professional development is going to be overall to all your staff members, right? So when you're thinking of professional development, I know that yesterday they talked about different types of fundings that are available for New York City to acquire professional development. However, I am going to talk about a strategy that I did with my schools when it came down to the professional development of my teachers. And we're going to talk about within the next steps, what am I going to do in order to ensure that everybody in my class is getting all the information that they need. All of my teachers are properly trained. So you have the option of being able to do professional development. But the next feature is going to be utilizing everybody's strengths to come up with sample lessons, right? That they can actually present in the classroom or into the other staffs. And my apologies, my little feline friend is barking a storm outside. Okay, so resource and allocations. So before you start doing your professional development, right, your resource and allocations is going to be the main thing. So, and I'll explain to you in just a second. Resource allocations follows budgeting and resource plannings have to be pragmatic and forward-looking. So aside from the obvious requirements like hardware and software, consider libraries, research databases, collaboration tools. Think of it as creating an ecosystem conducive to learning and research. So cost efficiency should be balanced with the quality ops for open course tools when it's suitable. But don't be compromised where it matters. So prepare your plan B, plan C, plan D as how you're going to be able to put this into place. And this is where I was going to talk about the resource allocations and how it could be utilized with your professional development and how they're both linked together. So on the following page, it should give you a model. So these are all the different models. And I know that it's geared mainly for elementary school, right? And one of the primary reasons is that when you jump into like the middle school and the high school, you do have more your elective classes. And yes, you are competing with, if you're a computer science teacher, you are like Dr. Cherry Fasali said, is that if you're competing with, your computer science is going to be competing with all the courses. However, after I explain one of the different things that I did with my staff in order to, during PLCs or during even faculty meetings, it brought that training into every single subject area, whether you were doing math, whether you were doing science. So even if your students were not put together into a computer science reel or path, and they were probably doing a different path, whether it's fine arts, you can still incorporate computer science into this particular path. So these are different ways that as a smaller school district or even a smaller school can look for some ideas of how to implement computer science in their program. So the one that I'm going to be talking about, which is one of the ones that I had access to starting, was the fourth one, which is the tech center or stations, right? So we were able to grab all the computers, and this is before one-on-one, this is before COVID. We were able to grab all the computers that were originally set forward to every single classroom and put them into a computer lab. And just like every single teacher was able to go in and take their students to art or take their students to music, they were able to take their students to computers, right? So for this particular one, and this particular school had the funding to put a person in there that not only was going to write the curriculum for every single grade level as to what they were going to be doing, but also they were able um, to planned with the different grade levels and create projects that when the students would come into the computer lab, they weren't only learning the actual computer science of it all, but they were integrating this to different areas of their given subject area. So if you look through the website and you scroll down to first grade, I want you to take a look at that, right? Because first grade is a vast example of what your resource allocations are. So when I came into this place, I said, okay, this is what we have that is for free. We need to make sure that all the students in K through fifth grade not only cover every single ISTE standard, but we learn from all the different tools that are here. So when they do go to middle school or they do go to the high school, because it was a K through 12 program, when they do go to these other grades, and I put in place what I wanted to do, which is that in middle school language arts, if the teacher wanted them to create a website talking about specific types of poetry, they had the background knowledge to actually build this, and then they can still focus on their ISTE standards, but departmentalized by subject area. So my research allocations, this was my plan ABC. So without even having a big budget, I was able to put this together. So I broke it down, and so just you see the examples, and there's not only photos, but there's also students' work, so you can see. But the first, since they were MacBook computers, right? So the first couple of grades, they were learning how to use. Not only were they using the typing, they were using Keynote, Apple numbers, and creating different presentations, but they were learning all the aspects of it. Now, if you notice that I shared with you a trimester lesson plan, right? So that particular lesson plan, the reason it was a trimester lesson plan was mainly because of the fact that I needed it to be it not only I needed my lesson plan to be to cover how I wanted to break down my program. So I knew that I wanted to cover robotics in there. I knew that I wanted to cover coding. I knew that I wanted to also be STEM related, but at the same time, I wanted to ensure that they also learned all these different softwares so that I was able to prepare every single little guy in there from K through fifth. So when we rolled over to middle school, not only would they be able to be successful if they were put into a STEM program, but because our school adopted that every single teacher had to also create projects that were geared towards enhancing ISTE standards. Okay, so if you roll over to all the way to the last couple of grades, and I'm going to go and show you. See if you notice in fourth grade, then you were, I believe I started in third grade, but we'll look through fourth grade. So once we rolled it over to fourth grade, because it was a Google school, I was able to start introducing Google Drive, Google Docs, Google Drawing, Google Sheets, and I put samples of different projects that we built with that in mind. So if you look at fourth grade, and in the state of Florida, fourth grade studies Florida, right? So they had to put together a website on the state of Florida. And with that website, they had to incorporate a movie. And now I met with their social studies teachers and say, hey, what characteristics of Florida do you want them to have in their movie? Their homeroom teacher put together the rubric of what she wanted, and then when they came into this computer class, they were able to actually build that within that classroom. But with this in mind, by them learning like different types of software, it made it easier for the classroom teacher that was not as tech savvy as she wanted to be. And it gave the students a place in order to being able to ask the questions. And again, this is, having the person at hand that is tech savvy that can actually go to those classrooms and help out those teachers if they want to do projects like this as well. So I am going to jump over to your pilot phase, right? So in building this particular structure that you're thinking about for your school, right? Don't be disappointed if your first year is not as successful as you want, because this is how we learn as to where we want to go. So on the pilot phase, and I'm going to go back and forth because for some reason on my screen, it's not showing the whole slide. Okay, there we go, pilot phase. Yay. Okay. So on the pilot phase, let's discuss the pilot phase. So rolling out a new program is always risky and resources are intensive. A pilot phase helps migrate these risks. So you have to choose a representative sample of a student and run a scaled down version of your program. Observe it carefully. How are students responding to whatever you're piloting? Are faculty members comfortable with the curriculum? And use this phase as a feedback loop to iron out any of the errors when you roll out your full scale. So if your first year, you're thinking of just having maybe language arts teachers think of a project that they want to incorporate, and they're going to do this project either using either using like Google or Microsoft Slides, whatever is it that your school has access to it, that it's already free part of the program that you can utilize. Maybe that's your first phase. Hey, every single teacher in this class, every single grade level is going to think of one project, right? And that project is going to incorporate our standards for New York and your standards for that subject, for that specific project. They're going to work together as a grade level. All those teachers are going to work together within their subject, within that grade level, to compile a project that's equally relevant to every single student in that grade level. So it's not just that really techie teacher always doing techie stuff, but now that really techie teacher in fourth grade is going to help with the techie, but the rest of those teachers are going to help with their input developing a specific project that can be launched in your school. So again, that could start as small as that in your specific school phase. Okay, so we're going to talk about evaluation and refinement, right? So we know that the pilot phase is going to be small if you're going to pilot something, but now you're talking about, let's say, okay, how am I going to fix whatever the issues that are coming up? So evaluation and refinement. So in launching a program, it's not the end, right? It's more of a soft opening. Collect quantitative data such as grades, completion rates, survey results, but also qualitative insights from interviews or focus groups. And I'll give you an example of what I told my teachers and what I always tell my teachers. One thing that I would always tell them is that, hey, great, build a project. It looks great on paper, but I want you to actually build it yourself. So if you're asking all these different things to be included in that project, I want you to build one yourself. Number one, it gives you a humbling feeling of what errors or what questions your students are going to ask you if they have any tech issues, right? So that's one of them. Number two, it's going to help you figure out the timing. So if it took you 2 hours to complete, chances are is that you have to make room for a 5-hour project for a student. So instead of saying, okay, this is going to be done in 2 days, now you're actually being a little more realistic of giving it a whole week, depending on what you're asking your student to build in, that's tied into all these different standards that you want to implement in your classroom. So Before I go to the next slide about, about the full scale, when I started this the first year, I started, building what each student needed to know. And throughout the whole entire 6 years that I was at that particular school, the projects became refined. But one thing that I did is that by the second year, all the teachers in elementary school were able to come to a professional development that we had at the beginning of the year, and they showcase how they incorporated their standards, their tech standards, with their core educational standards, and what kind of projects they did. And they had pictures of their students building specific either slide points, movies, green screen components that they were building, like whatever it was that the students were creating. Those elementary teachers in each grade level that came up to that faculty meeting and introduced that to the middle school teachers and to the high school teachers. And I started that faculty meeting with saying, okay, you saw what elementary was able to do. Now is your turn to learn from what they put together and come up as a language arts, science department, math department, a tech project that you're going to be working on through either a semester. So this way, they're still covering their core curriculums. They're just making it more hands-on. They're making it more to expose those students to a different type of learning style, right? That it's not just book and testing and papers, but if you're talking about, measurements, and they're going out and taking movies of different angles around the school for their math class. So it's just that kind of vision that you're able to give these teachers. So it's not going to be just one more thing on the table for them to do, but a way that they can bring this or tie this into their curriculum as well. So moving forward to full-scale implementation and what that looks like. And I'm sorry, I'm going back and forth on my slides, but I want you to be able to see them correctly and not halfway. All right, so what does a full scale look like? Well, full scale looks like is now you first start your initial with maybe one classroom, one group of teachers, one grade level, and full scale is your whole entire school, right? And it could be something as minimal as, hey, we're all doing hour of code, but we're not only doing hour of code on the day that we celebrate hour of code for in honor of computer science, we're doing it as a whole entire school. So I'm going to talk about what is a full-scale implementation, and then I'm going to give you and I'm going to talk over some of the links that I've gathered and how you can implement some computer science like coding or gamification into your curriculum that can enhance this kind of mental forwardness towards being able to integrate computer science into your schooling. So your full-scale implementation is transitions to a full-scale implementation is pretty much the crucial phase, right? Scalability is, I guess, the main keyword here. Can your pilot program be effective, replicated to cater to a large student body? Consider logistical issues, timetabling, classroom abilities, resources, and redistributions. Is a delicate act of balancing when it comes to expansion with quality. So think about that. It's a delicate act of balancing when you're thinking of expanding, but also having something that is quality and you have control over it. So monitor closely, be prepared for hiccups, and have a contingency planned in place. Perfect example. My computer, when I had everything set up, it hiccuped and I was like, okay, what can I do? And I had a plan B, plan C on being able to push things forward. So in one of and I know that I didn't hyperlink it to my next slide, but I am going to put that on the chat, and I'm going to go really quick and get it so that we can get it for you guys. And when it talks about starting small and integrating, like for example, coding into the classroom, I'm going to give you, let me get the link. I'm going to go ahead and link it and jump back over here to the chat. Okay, so if you click on that link without moving out of your Nearpod as well, right, you're taking a look at, and I'm scroll all the way to the bottom, there are different free resources out there, like for elementary, middle, and high school. So if you want to use Hour of Code, if you want to do Hour of Code to incorporate some computer science into your school, these are some of the different tools out there that are pretty much age appropriate for different levels. And I'm sure there's a lot more, especially now since so many things are popping up, because with the use of AI, you're able to code faster and create apps and games a lot faster than what you were able to do before it became public knowledge of how to utilize it. But with that being said, these are all the different tools that you can utilize in order to start this. So how did I started this as an administrator and as a computer and how I wanted to implement this into my school? So I picked one, and I'll give you an example. Codeable, right? So Codeable is really, really basic for little guys. And I created little tutorial videos for their teachers. I said, today we are going, you guys are going to press play and watch me teaching you how to do it. This is as an administrator, guys, not as not as a computer teacher. And then I created little accounts for all of them, and I had them battle out each other, right? And I gave those teachers a cute little who finished theirs first, little little rewards for that, right? Okay, so the bigger picture after I did this was the fact that I wanted all those teachers to do Codeable for 25 minutes every single day during the Hour of Code week, right? So now I had my kindergarten, K, and 1 teachers working on this particular task, right? I spoke to my computer person and I said, hey, I need you to create accounts that are easy for all those students to log in. And I created a quick Hour of Code website that I had all my teachers by name. So I had my first grade teachers by name, my second grade teachers. Okay, so if you are in Mrs. C's class, press Mrs. C's name. You click on it, and there they were, the links for every single little guy by name to click on and be automatically pushed over to do that particular coding activity. And it was and again, have a plan at hand. If for some reason somebody's account was oh, it wasn't working, or we forgot a student that was not on the class roster, you can always have other accounts freestanding for those students that didn't find their name for whatever reason. Okay, so continuous assessment. So let's go back to that specific topic, right? And we're still have 10 more minutes. I'm sorry. I'm going to rush as fast as possible so we can get everything done. Okay. So we talked about your continuous assessment. So monitor and access all your students' progress to ensure that the program effectively impacts and intense knowledge and skills, adapt the program as needed. So what exactly does that mean? Okay, so monitoring should be ongoing, focusing both on your immediate outputs like grades and long-term outcomes, career success, and academic contributions. So by me teaching students to do Excel and doing a fun Excel activity in elementary school with the stock market, and you can go back to that later and you can look at that, because I want to say I did that with 5th grade. All the kids wanted or loved it so much that the school was able to put together a stock market class for students to do the following year. But how amazing is that? Because you know what? Now we know with the stock market and all the apps that are being built out there, you have to be somewhat computer savvy. You have to kind of understand it. And talk about, learning about algorithms and tying that into a high school class, how algorithms, kind of function in in a program such as, figuring out the stock market and what stocks algorithms are being successful and which ones are not, and what predictions could be made, which are all the things that you can teach that also are linked to courses in algorithms in college. So again, plan with your students at mind, and little tiny success stories can always evolve to big success stories when you are putting something together. So continuous assessments, constantly ask your staff, what can I do for you? How can I make your job better? Sometimes it's as simple as, hey, I need new headsets. My students need headsets, or the mice are not working properly and they need it for their Chromebooks. Sometimes it's the little things that make them happy, that the teachers realize that, hey, my administrator's listening to me. I know they want me to be able to do this, and I want to do this, and they're actually giving me the tools in order to get to where I need to be. Okay. So moving forward to program evaluation, right? So finally, let's delve deep into the concepts of program evaluation. Now, why is this important? Well, imagine launching a highly successful program today that becomes obsolete in 5 years, right? The field of computer science is ever changing, and your program must evolve to keep pace with new advancements in technology. So methodologies, social needs, failing to do so could risk stagnation and decline, right? And a perfect example of this is that, and this just came out yesterday or the day before yesterday. I'm not exactly sure on the exact date, but, Google Education was getting rid of a specific tool that we're all very happy to use. And a lot of teachers have created projects in that. However, Figma, which is another software, is being able to transport the stuff that you had in that particular um, design that you were using, and they were able to convert your stuff. So now, in order to change, let's say you were teaching students to do projects in this particular software, and that software is no longer going to be available. It's like, oh well, this new one is now available, and how is this one able? Well, if you know about Figma, allows you to actually build your interface for your apps and for web design as well. So that's what it means by being able to stay and change, because technology is constantly changing. So not to just think or be set on doing the same project for 15 years without changing with the project around with new technology, so the students always stay relevant. Okay, so you can think of a program's evolution as a cycle that consists of 4 key elements. So I'm going to go ahead and change. Hold on a second, because I'm going through my website and I'm going through. Okay, so sustaining the program, right? So we know that we have to maintain staff training. We can seek community support, and we can always update our curriculum. And I'll give you a perfect example. Yesterday, I had to volunteer at my niece's school. My sister-in-law unfortunately passed away, and so I had to go and do some volunteering. And they were launching STEM night, and I was like, count me in! I love this. And one of the things that I met with the educator, when we were the administration, when we were planning this particular event, was the seeking community support, right? So we reached out to different companies around the community to help us out with maybe things they wanted to donate, so that we can actually have a STEM career, or a STEM track for that given day. Are they donating cups? Are they donating rubber bands? Are they donating boxes? So seek community support. with that being said, there's many companies out there that can also donate different items to your computer science program. Um, I've had the very lucky benefit of, like, we didn't have a robotics table so that our kids can actually compete the robots that they built, and we reached out to a local company that did building, and they actually built us a with scraps of wood. They built us a robotic table that we can utilize in our school. So seek community support. Update your curriculum. Like I mentioned earlier, technology is constantly changing, and technology and our standards are constantly moving along. As you can see, ISTE, the White House, and all these, even the state of New York, changed some aspects of their technology spectrum due to the infrastructure being now having to adapt to different AI items. So, and maintain your staff training. If you have the funding possible, send them to training. If you're a teacher, and no administrator is going to tell you no without thinking of different solutions of how they can help you. So if you're a teacher and you say, hey, I really want to be able to do this, but I want to take this specific class, what can I do if you can't send me there? ISTE, and just this at hand, there's so many knowledgeable people that have the content or the ways that they can help you to being able to put this together in your school. Okay, so let's see our next slide. Okay, so we went through the whole entire blueprint, and you can scratch off as to, like, hey, do I already have a vision for my school? Check. What curriculum design am I going to use? Okay, so I know that there's different different things that I have to ensure that each of my grade levels are exposed to based on the curriculum guidelines. Okay, do I have the right people for the job? Am I ready for this? Okay, so if I'm the person that's being asked to do this, now my next thing is, what am I doing to teach myself to become better, to reach out to people in order to being able to plan my professional development? Now, one of the really big reasons why I love Twitter and how I am a member of the Twitter community, it was not necessarily because, oh, I want to post about everything or I want to know what's the latest gossip out there. But there's so many amazing teachers out there that post such great things that they do with their students that I was like, oh, I love that project. And if I had any questions, I would reach out to that teacher. Hey, like, what what were the highlights of this project? Like, what were some things I want to do this with my class? What worked? What didn't work? How long did it take you? And just by reaching out and looking at all the great things that people are doing out there, it's such a great, you don't need tons of money. And I understand that time it's also hard because there's so many things as teachers we're being asked to do. But at the same time, how great it is that we have the means and technology to be able to research all the different things out there that can work for our students and to make our curriculum even that much stronger. Okay, so I'm going to go back to and I'm going to go to the chat really quick. So if you guys have any questions for me, anything that I can answer for you, I would definitely read it on the chat and I can answer it for you. Let me see. And let's go back. All right. So let me go ahead and hit the back button, the next button for the next slide. Okay. So with PD in mind, guys, and whether you're a teacher, whether you're an administrator, if you scan the QR code, it could take you to free professional development. I did mention that I was a curriculum coach for Samsung, and after retirement, my passion for being able to to teach other teachers about what I love and how passionate I am about technology, this is a way that we can do it. And Samsung, thank goodness, has the allocations enough that we can do free classes for teachers. And there's a huge catalog of different workshops that we offer. In addition to that, we, whatever. Oh, okay. I will. I'll share the link to the Nearpod as okay. Okay. I also the Nearpod was based on. Thank you, Kelly. The Nearpod was based on the Google Slides, and it has all the QR codes and everything on there, and the Google Slides also has all the hyperlinks to the website. It has hyperlinks to all the different things that we spoke about. So I'll go ahead and ensure that all those things are on there after our presentation is completed. So with that being said, guys, thank you so much for your time. And thank you so much for bearing with me with all these technology hiccups that we encountered. But one of the great things about technology is there's always 100 different things to counteract whatever comes at us. And I'll make sure that I tell Tom, hey, I wasn't able to get back on my screen. And thank you guys. Thank you so much for your feedback. And on here, if you guys don't mind, on the QR code for the feedback, where it says Samsung feedback form, and I have it also on my Google Slides. If you guys complete it, since you have to put in your name, I will go ahead and send you everything. I'll send you the links to everything that I created, including the Nearpod as well. As a matter of fact, before we leave, I'm going to jump into Nearpod, and I am going to, give me 1 second, guys. And I am going to do the student pace one, which gives you guys access to that as well. So here you guys go. Here's your Nearpod, and that's the one that you can see it at your own. If the code didn't work, I should have, my bad, I should have added that from the get-go. But anyhow, thank you so much, everybody, for your time, and hopefully you got a lot of resources from this